is full of surprises and good and bad. There are moments of joy, others that make you sad. Finally what matters is how you take it all. Keep the ball rolling, rise up if you fall. Everything we do depends on what we believe. Thoughts and beliefs reflect what we perceive. So it's time for some introspection. Time to look out for the self-deception. Once you realize and change the perception, and let there be a new projection of a brand called you, of a brand called you, of a brand called you, of a brand called you. I bet you have some value systems. What are your aspirations? Why do you think you're not good enough? Do you know to someone you're an inspiration? Open up to life and expand your vision. New possibilities are there over the horizon. So walk that road to self-discovery and help people see what you truly are. And if you peel off your inhibitions, the world will see the bright shining star. In a brand called you, in a brand called you, in a brand called you, in a Life is full of surprises and good and bad. There are moments of joy, others that make you sad. Finally what matters is how you take it all. Keep the ball rolling, rise up if you fall. Everything we do depends on what we believe. Thoughts and beliefs reflect what we perceive. So it's time for some introspection. Time to look out for the self-deception. Once you realize and change the perception, and let there be a new projection of a brand called you, of a brand called you, of a brand called you, of a brand called you. I bet you have some value systems. What are your aspirations? Why do you think you're not good enough? Do you know to someone you're an inspiration? Open up to life and expand your vision. New possibilities are there over the horizon. So walk that road to self-discovery and help people see what you truly are. And if you Life is full of surprises and good and bad. There are moments of joy, others that make you sad. Finally, what matters is how you take it all. Keep the ball rolling, rise up if you fall. Everything we do depends on what we believe. Thoughts and beliefs reflect what we perceive. So it's time for some introspection. Time to look out for the self-deception. Once you realize and change the perception, and let there be a new projection of a brand called you. 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 I bet you have some value systems. What are your aspirations? Why do you think you're not good enough? Do you notice someone you're an inspiration? Open up to life and expand your vision. New possibilities are there over the horizon. So walk that road to self-discovery and help people see what you truly are. And if you peel off your inhibitions, the world will see the bright shining star.
Hello, hello, hello. Hello, hello, hello. Hello everybody, welcome to our channel Econstruct Designable Private Limited. Today we are thrilled to announce that we are going to start a new series of webinar in which interesting topics would be there. The first topic that we have come up with the performance based design of a particular building by using the ASC norms, ASC 41. As per the latest code, Indian code, unfortunately in India we do not have the performance based design. So we have to rely on the foreign codes. No doubt about it that it's a really painful procedure, but you need to really work it around to see that how basically you are going to start doing the performance of a particular structure. So what is the performance basically? So let's say I'll give you the one particular example. This is my mobile. All right. So in the the cost of the mobile may be like, for example, 1 lakh rupees, and if it falls down, it's gone, unless and until you are having a cover to this. the one tempered glass and the proper cover, so that it will protect your mobile. So what I'm trying to say is, any structure is there, any building is there, and if you really want to do the increase the performance of a structure, um, what exactly you will do so that the performance of a structure can be increased. For example, I'm increasing the performance of a mobile by designing and by adding this particular cover. Front side there is a glass, and the back side there is a cover. So there is a glass cover as well as there is a tempered glass cover, as well as there is a backside cover. So similarly for the buildings, what exactly as a structural engineer, as a civil engineer, you will do to improve the performance of a structure. So this entire session is particularly for that. And I'll be shortly showing you or demonstrating you one particular small project, the test or a demo project, in which how you can improve the performance of a structure, and what the theory is saying. From the CSI Berkeley, that's a company where the Etabs, Safe, SAP 2000, this kind of software they have developed it, and they have recently upgraded their tool to do the performance check or the long-term performance analysis of a structure. So how do we do that? So let's get started with the slideshow. Just give me a second. Alright, so this is basically the energy diagram. Okay, so there is a lot of theory that is involved into this. Energy diagram means, actually, what is this? This is basically the modal damping. Okay. After the modal damping, you will see that there is a potential energy, then there is a kinetic energy, and there is this particular space. This space is basically the deflection or deformation. Okay, so imagine that there is a structure here and there is a mass here, and if there are basically the ground motions, you will see that the deflections and the mode shapes will start. The mode shape will not start immediately after the ground motion is started. So what will happen is, initially there would be certain absorption of the energy that will happen through this particular area, what we call it as the modal damping. So mode means actually the behavior of the structure in such a way that it will try to balance the forces that are getting exerted at the ground surface. Immediately something, the ground motions have started immediately, the building will not start dancing. So similarly, for example, if you go to a any workshop or seminar or presentation, if I play the music, immediately you will not stand up and start the dancing on that particular music. Why? Because inherently you have gone there to do the workshop. So initially there would be as a nature of a person, it will be the modal damping. So even though the music is good and all actually, and you really wanted to do some kind of dance, but still you will physically not do that because of the nature of yours. So similarly, the structure also, whenever the earthquake comes, immediately the structure will not start dancing. Initially the resistance will be offered through the modal damping. After the modal damping, then there is a potential energy, and then there is a kinetic energy. What is potential energy? Potential means the potential of the structure to lean the structure at a particular place. Sometimes the potential energy will get converted into kinetic energy, and even though if the forces are not getting balanced, then it goes to the deflection or the deformation. Alright, so this is the entire theory of this energy diagram. So like that, many different theories are there, and how the energy absorption will happen. As you see that here there is a time period, here there is energy, and how the forces are getting transferred and the energies are getting absorbed. This is the theory behind it. So as I told you, the long-term performance, You might be knowing that a lot of information is there related to the deformation and force and the displacement. So this is basically the deformation, and this is the force. Okay, so this is the stress strain curve. So up to here there is a linear curve. This is the linear analysis, and then it goes to the non-linear analysis. This is non-linear analysis, right? So at a particular point the structure will behave non-linear. Okay, till that particular point the structure will start behaving the linearity. So whatever the amount of stress is there, similar amount of strain would be there. The stress would be like force, strain would be generally denoted as a deformation. So implied nonlinear behavior is like this, right? Then steel's stress strain relationship. How does it work in the steel cases actually? So what is this diagram and what is this diagram? Okay, so this diagram is basically the actual diagram, and this is nothing but the idealized diagram. Okay, what is actual diagram is, this is the stress strain curve, this is the stress versus the strain, this is stress, and there is an upper yield point over here. Okay, then it goes straight, and then there is a necking point, and then it goes to the failure. So this is basically in terms of the radian, how much would be the the displacement and how much would be the stress given. So initially from this to this zone, it is known as the elastic zone. So at any moment of time, if it reduces the stress, the strain will get reduced proportionately. Alright, so from here to here it is elastic or and plastic zone, or this is also known as elastoplastic zone. Plastic zone, and then there is a strain hardening. Alright, so how this is basically the theory part. So it is very difficult to design the program or the software like with based on all these principles. So in order to idealize through the program, it is just given like this. So this is elastic zone and there is a plastic zone here. Alright, so depending upon this actually the program or the behavior of any particular hinge point is designed. Now this is inelastic work done. Now what is this actually? This is basically the hysteric curve. Hysteric curve means, let's say there is a bicycle here. Generally I give this example in my class also. Okay, this is a bicycle. Okay, in which you will see that actually whenever there is a pedal, the bicycle is trying to go in this particular direction. So if you put the force on it, on this particular pedal, the bicycle will will try to go in this particular direction. It will definitely start moving in this particular direction. Imagine instead of a man, a small kid is there. The force is very less, so bicycle will not start moving also. So entire energy is basically absorbed by the modal damping in that case. But if the energy is bigger, if the big man is there, actually automatically we'll see that the bicycle has started moving. So similarly here, it is based on the how much amount of force that you are putting here, the similar amount of bicycle is started moving in this particular direction. So it is basically the linear behavior. The moment the bicycle is going a little bit faster over the period of time, you don't need to put the force onto the pedal, but still the deformations will start. Okay, without the force applied, the deformations are happening. There is no increment in the force, but still the deformation is happening. That is non-linear behavior. That is non-linear behavior. Alright. So how basically you can do this? How exactly you can strive for all this? So that is this particular study, which we call it as the inelastic behavior and all. So there are so many hysteric behaviors are there. So initially hysteric behavior is going like this. Okay, the bicycle is going like this, but over the period of time the displacements would be more, and you are not giving any particular force. There is no force, but still there is a more deformations or displacements. So that is the hysteric behavior. So moment, rotation, and all this forms actually. How do we do that? Okay, so there is elastic, then there is elastoplastic, then there is a plastic, and there is a strain hardening. So there is a theta here and there is a moment here. So previously there was a force and there was a displacement. Alright, now there is a moment and there is a theta, which we call it as the rotation in terms of the radians. So these are all theories basically. The CSI has successfully added into the program. Idealization, bending moment, ductility. Yeah, I would like to explain this slide. This is a very important slide basically. So there is a drift and there is a lateral load. So how much is the force? So let's say for example, this is the building and you are having mass 1, mass 2, mass 3, mass 4. So this is ground floor, first floor, second floor, third floor. So whenever actually you are having the ground motions, the structure will start, moving in this particular direction. In this particular direction. Okay. So whenever the direction of the force is actually, whenever the higher the force would be there, the the displacements would be more. But if your structure is brittle, if your structure is brittle, what will happen? The building will not start moving in this particular direction. It will be just brittle, like a chalk. Okay, so imagine instead of a chalk, it's a steel rod. So automatically it will bend. But if it is a chalk, it will start breaking. So that's why in order to not to have a brittle nature, in order to have a partial ductility or more ductility, there is a separate code for this, what we call it as IS 13920. This is the code basically to increase the ductility, increase the ductile nature. Alright, so that code, what it is generally explaining you is basically how the ductility clauses are there and what kind of norms are there, the spacing between the rebars, how much top rebar, how much bottom rebar, how much would be the. So let's say for example, there is this particular column, there is a beam here and there is a beam here. So in order to have a ductile nature, you need to give a lot of closed spacing rebars over here, the vertical stirrups, here also, here also, here also, as well as this side, this side, this side. Okay, and the other part actually, let's say this part, it can be a little bit, if the spacing is a little bit more, that's okay, that's not a problem. But I need the ductility zone basically over here. This is my ductility zone. This is also my ductile zone. So these are the zones where whenever there is a lateral sway that is happening inherently to the structure, whenever the column and the lateral sway is happening at this particular junction, there would be the plastic hinges that may form and that might collapse the structure. If you see the Bhuj earthquake or Killari earthquake photographs and all, actually because of the ductility problems only, the maximum amount of failures that has happened, guys. Okay, so there is no partial ductility or ductile nature, or everything was brittle. The amount of reinforcement given here was not proper. There is no ductile areas. So that's the reason, the failures has happened. Alright, so how do we basically, do that now? You have understood all this actually. There are so many slides are there, capacity designs or shear links and all actually. Yes, as per the FEMA 4451 norms, This is also the as per the US Resiliency Council. The building is basically designed based on the four principles. One is operational, fully functional. Then the second one is basically the immediate occupancy, that damage is there but it is quite less. The third one is actually life safety, and the fourth one is the collapse prevention. So these are basically the performance levels depending upon the amount of damage, less damage or more damage that is happening to the structure. This is what actually it is considered. All right. So apart from this, I would like to just show you. Just a minute. Yeah, these are the performance levels of this actually. So this is basically based on the ASC 41 norms. ASC 41 also gives you different types of models: immediate occupancy, life collapse prevention, life safety, and all actually. So what are the figures actually? Percentage of how much, how you can determine that it is immediate occupancy level at this level or at this level or at this level or this level. So depending upon that actually, the ASC has defined that the structure comes out under which particular category and all. Alright, so these are certain areas and the norms are there which you can just figure that out. So let's say for example ASC 41 beam model, how much rotation is there? So let us say for example, I'd like to show you this thing. So let's say somebody is twisting my arm, for example. Okay, so he's my friend, so it's okay, no problem. Okay, but if the twisting is coming a little bigger, then I'll start, oh, this is too much now. Then again, if it is twisting even more, then I'll start screaming. It is going to a level where my shoulder will get dislocated. I'll start screaming like hell because I don't want my arm to get dislocated. Now why am I screaming? Because there is already a sensory body. The sensors are there inside the body. But in the structure, in the model, there are no sensors. So we need to apply the mathematical sensors over there. We call it as the hinge points. So that is the non-linear hinges. So what are the different types of hinges are there? The rotation hinge capacity, what are their capacities, what are their failures, what are their levels. So those hinges will give the signal like, this is getting dislocated. So this hinge has given the signal to my brain that now this is enough. I know that this is too much. It will not come to them. This is not a game. This is real fighting that is happening. So obviously, I'll start screaming. So this is how actually the ASC 41 is trying to, see that and put that properly. So this is that ASC 41 norms actually. So this is immediate occupancy, life safety, and collapse prevention, and these are the figures. Now somebody will say, sir, enough of theory actually. Let me see some practical. So I would like to show you one particular structure. This is the building I have created, in which it is just the 10-story building. I have just given this particular dimensions and all actually. I'd like to unlock the model. Okay, so what I'll do is I'll first of all select the objects of the beams and columns. Alright. So let's say initially I'll select only the beams. From here I'll just select the beams. It is a concrete structure. So I'll just go here and go to the frame structure and go to the hinges. So this is the hinges actually, and you can give, I'll just delete the previous hinges and give this auto clear as, let's say, 0. Add this as a concrete beam. Just say okay here, and then I'll add a 1 as the same hinge actually. And this is a concrete beam, and I'll just say okay here and okay here. So this hinge is applied. So now I'll go to the select object type as the columns now. Again I'll go to the assign, frame and hinges. Now here actually I'll replace the existing hinge. Actually this is 0, so relative length is 0. From here I'll, instead of now concrete beam, I'll go to the concrete columns, and this is M3. You can give this option to the M2. This is, what is this? This is basically the minor bending moment. Yes, this is the major bending moment. This is the major and minor bending moment. This is PM2, this is PM3, this is PM2M3. So this is axial force and a biaxial bending moment. And there is parametric equations also are there. So yes, these are certain advanced levels, but I would, at the first moment actually I would like to show you the degrees of freedom, which is M3, which is the major bending moment. You can also go to the M2, M3. It depends upon the requirement of yours. So let's say I'll go to the M2, M3, no problem. And I'll just say OK here. So this is a concrete, and I'll also go to the 1 here. Now somebody will say that, sir, what is this 0 and 1 and all actually. Now I'd like to show you that, let's say this is the beam. In this beam this is 0 and this is 1. This is 0, this is 1. So any particular beam is there, this is the column. The 0 is exactly at the center of this particular junction. So this is at the starting point, which is 0, and this is at the end point, which is 1. Now there are certain theories actually which you guys can explore it later on. Now let's say there is a column here and a beam here and all, and you don't want to see the hinge here, because this is not the place where the failures will happen due to the earthquake and all. The failures will start exactly at the cross section of this particular phase. So this particular hinge point, you can easily go to this particular place at the face of the column, at this particular face of the column, also here and here and here and here. So these are the faces actually where you can give this non-linear hinges. The moment you are given the non-linear hinges, so automatically it will act like a real type of body, and you will see a lot of difference actually. So let us study this actually, and let us go ahead. Now these are the parametric equations and non-linear hinges. I have given it to you, this particular place. These are the columns. I have said just say OK. So you can easily see that there are hinges here, hinges here, hinges here. Like I told you initially, this is my arm actually. It is a sensory body. So somebody is twisting my arm. So automatically these senses will tell my brain that this is not right actually. It will get dislocated. So similarly, whenever you are giving the ground motions here, and these hinges will give the signal to the software that after doing the analysis, that whether it is okay or not okay. All right. Now let us go to the other places. Like I'll tell you that I'll just define the mass source. I'd like to unclick these two, click these two, the 1 time dead load and 0.5 times the lie load. Then I'll go to the, let's say, the load patterns. So dead load, lie load, earthquake load, we will be giving you know that already, that all these particular parameters we need to give it as per the code, which is IS 1893-2002. This is X plus eccentricity minus eccentricity. This is Y plus eccentricity minus eccentricity. These are the Z values, which is basically the seismic zone. Then there is a soil type. There are so many types of soil, hard soil, soft soil, medium soil, importance factor. Then there is a time period. The time period formulations are there, 0.09 h upon square root d, and many different other time periods or formulations are there. So yes, some people are asking in the through the WhatsApp chat that the time period formulas. So 0.1 n, this is one particular formula time period. Then the another time period formula is 0.09 h upon square root d. Then t is equal to 0.075 h raised to 0.75. Then t is equal to 0.08 h raised to 0.75. then 0.085 h raised to 0.75. Okay, then T is equal to T, Etabs is also there. Alright, so one question and so many different answers depending upon, this is for the thumb rule calculation, this is basically for the infield wall, these are without infield wall for steel structure, composite structure, this is basically for calculating the actual time period based on the mass and the stiffness. So based on this, if you would have given this all the figure, just say okay here, then you go to the another load cases. So let's say I'll be giving to the seismic spectrum x and y, and I'll be giving the non-linear time history functions. So th, actually this is the time history, non-linear time history function, and I'll be giving the time history function also over here. How to give this particular function? You go to the define, then go to the function and go to the time history function. So over here you will be giving, let's say already I have given, but I'd like to show you. You go to the match the response spectra, go to the add new function, and here you will be selecting the function which is the target response spectra, and the time history function also you can define it here. And once you are done that, actually you can change, this is basically we call it as the synthetic earthquake function. Now what is synthetic earthquake function? Synthetic means synthesis of time history and the response spectra from here to here. Now this is very interesting, guys, actually. What is this? This is basically, if you see that, this is earthquake actually. So if you take one particular plain paper, and if you take a pen here, and due to the movement of this particular paper, the earthquake will be there over here. So this is nothing but the time history. What is time? This is the time, and at any particular time, how much is the history, means how much it has gone up, came down, gone up, came down, gone up, came down. So that is time history function. Right? This is both are earthquake only. This is basically the actual time history function, which is getting changed into the response spectra. Now this is, now somebody will say, sir, what is interesting into it? So how to change this? The change is happening through the Fourier series transformation. Fourier series transformation. Now somebody will say, sir, what the hell is this actually? This I have studied in engineering, second year engineering somewhere, M2, M3, that particular topic actually. I don't remember this. So you don't need to remember, to be very honest. You just need to remember this is a mathematical function. What is this? Math function. This will help you as a civil engineer, as a structural engineer, to convert this into this. Now how does it convert actually? So let's say this is in blue color. So I'll give this in blue color. It goes like this. Now let's say there is another earthquake. This earthquake, the pink earthquake, is basically the, let's say, Bhuj earthquake or Killari earthquake. So this will go like this. Then there is another earthquake. Let's say Koina earthquake. This is another function. So Koina earthquake will come like this. So this particular, response spectra is blanket of all the other functions. It is covered with all the functions. None of this particular dot will be going out of this, not possible. So this is the worst of all the earthquake which is given over here. So that's why if you see from Jammu, Kashmir to Kanyakumari, from India to Australia or to America, many places, most of the time people are using the response spectrum functions. Only few people for dissertation and for specific problems, cases, people are using the time history function, because the time history functions are not readily available in the market, guys. Okay, that's why it is very important for you to go through this. So let us see that how we can give this and run the analysis. So after you do this, you just click here. Automatically you will see that this function has been transported here. Just say OK here and OK here. After that, you just create this load cases, which is th1, th2 by giving this particular function over here and give the scale factor. Now this scale factor you will be giving a little bit higher, guys. Okay, so how to give this particular scale factor? ये कैसे scale factor higher दे देंगे? What is basis of this? इसका क्या basis है? Yes, good evening Chandresh Singh, how are you? So ये किस तरीके से है actually? How to give this particular scale factor? So it is to be given a higher scale factor. Now how much higher is depends upon the problem statement for you guys. Okay, so there is no scientific method that how much particular factor you will be giving. So it is something like, from where you are going to break this actually. So, so what happens is we generally give a little bit higher in such a way that, let's say 5 times, 10 times, 20 times, 100 times higher. So that, if any kind of earthquake comes actually, my investment inside the building will not become zero. I repeat, my investment in the building will not become zero. Otherwise, building to todna padega. We have to basically break it down. So how do we do this actually? How do we do this time history analysis in Etabs for doing the performance analysis? So this is how it is. So just press OK here and OK here and then start running the analysis. Now it will first run the linear static, then it will run the modal analysis, also it will run the time history analysis. So all the types of analysis it will run at one particular go. So after doing this analysis, you will see that this is the deflection shapes. So दोस्तों ये क्या दिखा रहा है ये दिखा रहा है कितना deflection है, how much deflection it is coming. Now the deflection किस तरीके से दिखा रहा है, ux, uy, uz और rx, ry, rz. What is ये ux, ui, uz क्या है? ux, ui, uz. This is basically the linear deflection. And rx, ry, rz is rotation. जैसे किसी ने ऐसे हाथ ऐसे बेंड किया है, तो दिस इज बेसिकली द रोटेशन. नाउ इन विच पर्टिकुलर दोस्तों किस में आ रहा है, तो दिस इज कमिंग बेसिकली इन द डेड लोड डिफ्लेक्शन. Now I do not want the dead load deflection, I want something else. So you can go here and instead of a dead load here, you can select, let's say, earthquake, or let's say earthquake load deflection. See here you can see that the earthquake load deflection is coming. So this is how actually the earthquake deflection in the x direction is happening here to the structure. So this is that animation. Understood? So similarly you can select any type of, let's say I wanted to check the time history analysis. So I'll go to the time history and I'll give some particular time period over here. So this is that, time history analysis. So this is basically the time history, step number 3 of 100 in mm. This is the time history number 1, time period as 0.3 seconds, and this is the deflection shape of the structure. So whenever the जब भी earthquake चालू होगा तो 0.3 seconds में building का behavior इस तरीके का आएगा. That is what it is showing. Understood? Okay, so Sushant Giri is saying very grateful for this webinar. Thank you Sushant, thank you so much. Okay, please, I'll be conducting a little bit more webinar. I'm really sorry, this year I'll be a little bit more coming to the webinars and all other places. Last year, due to certain personal things, actually I couldn't able to come online frequently, but I used to give certain videos. But this year actually I would like to give certain very insight people inside things about the civil engineering. So please make sure that आप चैनल पे आ जाए, सब्सक्राइब करें एंड जो भी बेल आइकन वगैरह वो चीज़ें वो दबाएं एंड जब भी नोटिफिकेशन आता है एवरी फ्राइडे आई एम थिंकिंग टू कम इन द इवनिंग 7:30-8 बजे के करीब मैं आऊँगा और आपको जो भी कुछ नॉलेज है वो देने की कोशिश करूँगा. ठीक है, तो आप भी ये पर्टिकुलर स्क्रीन को लाइक और सब्सक्राइब कर देंगे ताकि यूट्यूब चैनल को वो रिजल्ट पता चलेगा कि ये whatever actually the content that I'm listening from here, I'm gaining certain things out of this. Okay, so time history function क्या होता है? What is basically the time history function? ये बहुत कम जन जानते हैं. बहुत there are so many less number of people basically they are learning this, they are knowing this. So what are these actually? यहाँ पे this is auto scaling. So how much it is going here and all. So whenever you are actually stopping the analysis and whenever you are basically hovering your mouse, so you can see that RX, RY, RZ, UX, UY, Z. So it will give you the intensity, how much it is going in X direction, Y direction and all. Okay. So ये तो deflect हो रहा है. This is basically getting deflected. But I wanted to see that is it really screaming that initially I told you that somebody is twisting my arm. So I'm basically screaming that, oh, this is stop. Why? Because my arms will get dislocated. So similarly, whenever the ground motions are happening here, whenever the huge amount of ground motions due to earthquakes are happening here, at that particular moment of time, when the columns are going to scream that now this is enough. For that, actually, if you remember, we are given the non-linear hinges. Okay, so what is this non-linear hinges? This is also one type of mathematical operator. So many a times, बहुत बार क्या होता है सिविल इंजीनियर्स को पता नहीं चलता इतना सारा मैथमेटिक्स क्यों सिखाया जाता है. M1 है, M2 है, M3 है, M4. There are so a lot of mathematics is there actually where it is to be because we need to use such kind of mathematical operators. Okay, and you should know at least some what is the real function of that particular mathematics. I'm not asking what is Fourier series transformation. You show it to me. What is nonlinear hinges and what is basically Newton's Raphson method and all actually. It is getting used into all these mathematical expressions. So how to basically use this mathematics to get the output from this particular software. So here you will see beautifully that there is a IO, LS and CP. What is IO? Immediate occupancy. LS, life safety. CP, collapse prevention. These are the acceptable points as per the US Resiliency Council. Understood? So once you do that, actually just press OK here and ask the software only that where this nonlinear hinges are happening. Is it really happening or not happening? So I'll go here and ask the software about the performance check. So I can go here and ask the performance check. So this is life safety. Yes, so you can see that most of the columns are failing, guys. The figures over here, these figures has to be less than 1. I given the force which is 100 times more. So all the columns are failing. And certain beams are also failing here. Understood? So it gives you the signal where and all actually the failures are happening. So what I'll do is I'll try to reduce the force and check again. So I'll just go back to the same place, go to this particular place. So instead of this, I'll give 10,000 as the scale factor. Now somebody will say, sir, how come 10,000 you are giving? Is it right or wrong? No, what I given is there is a scientific reason actually. What is the G? G is basically 9.81. This generally it is into 1000. So 9810, it should be the actual scale factor, which is the complete G that you are giving in the horizontal directions and all. But generally, if you ask me, the scale factor is VB bar is equal to AH into W, and there is a VB. So this is the static base shear. This is the dynamic base shear. So VB bar upon VB, this is basically the scale factor. Okay, multiplied by the existing scale factor actually. So this is actually the scale factor that you need to give. Alright, so maximum scale factor as per the program's default value is 9810. Initially I given again 00 here. So huge amount of force I have given just to showcase you some certain things. So I'll give you the actual force and let us see that actually is it really okay. So I've given 10,000 here and also the 10,000 here. Now I'll run the analysis and see the results. Okay. So whenever it is doing the analysis, you will see that actually how the results are happening. So I'll just press here again the deflection. If you want to see the deflection, this is the place, but I would like to see the performance rating, and I'll go to the immediate occupancy. Yes, guys, these are the places where it is failing. Where it is failing. This is the place. This is the place. This is the place. This is the place. So if you give the column or certain things like this, so the column is there along with that, something like this. So at this particular place, if the performance is more, it is just like you are adding certain cushion to your building. All right. So this is how it is. So immediate occupancy. If you want to go to the life safety collapse prevention, you can go for it, but I would like to go for the immediate occupancy only like this. So now I wanted to see the entire behavior of the structure. Okay, so the performance of the structure. So I'll go to the display performance check by using the ratio diagram. So this is the performance actually, life safety collapse prevention and all. Actually you can go for different checks and all over here. Apart from that, actually you will go to the display combined story response plots. Now this is a very important graph guys. Okay, तो मैं इसको थोड़ा सा आराम से बता देता हूँ, इसको थोड़ा समझना बहुत ज़रूरी है. So can you see here the dot which is moving? देखिए dot move हो रहा है. Can you see that? The red color dot. देखिए the dot is moving. The moment dot is moving, this is basically the acceleration versus the time. Time चल रहा है और earthquake हो रहा है. Time चल रहा है, earthquake हो रहा है. Time is going on, earthquake is happening. Time is going on, earthquake is happening. Now what is my behavior of the structure in terms of the displacement? So you can see that these are the maximum values. These are the positive values, these are the negative values. What is the drift? Mm divided by mm. This is the drift. Drift has got no unit because it's unitless, mm divided by mm. So somebody asked me this, I didn't get drift mm by mm means what actually? It is a relative displacement. So let's say this is a building and there is a displacement here. So there is a delta 1 and there is this is delta 2. This is delta 3 and this is the displacement. Whenever the earthquake happens, there is a displacement of a building will happen. Hai na? Then later on, this is the height. So this is L1, L2, L3. So delta 1 minus delta 2 divided by L1 is the drift. So the unit of this is mm and this is also mm. So mm divided by mm. So that's why the drift has got no unit. So generally what would be the permissible drift? It is basically 0.004. What is 0.004 is 1 upon 250 is the 0.004. So h by 250 is the maximum story drift that the building should carry. उससे ज़्यादा आता है तो फेल्योर है. Okay, so these are the figures that you will learn it from here. How much would be the maximum displacement of the earthquake actually? That is h upon 250. The total height I'll consider at h, and how much is the maximum displacement? So this is, let's say, 300 mm example actually. So 300 divided by what is the height? Let's suppose this is 10 story building, so 10 into 3. Okay, 3000 rather, because this is in mm. So how much is that particular figure? Has to be lesser than h over 250, then it is okay. So like that, the shear force, overturning moment force, all this study that you will be doing. So this is what actually the entire performance of a structure. जो डैशबोर्ड रहता है ना, आपने मोबाइल खोला, मोबाइल का डैशबोर्ड चेक किया कि मोबाइल का क्या परफॉर्मेंस है. मोबाइल तो क्या 40,000, 50,000, 1 लाख तक का रहता है. बिल्डिंग आपकी करोड़ों की रहती है. तो यू नीड टू सी द परफॉर्मेंस ऑफ योर बिल्डिंग एक्चुअली. Okay, so at least the father and son should live in that particular building. That's what actually it is. The real estate is really important in that area. So this kind of performance really helps you to find out which are the areas to be covered, to see that if you strengthen this, that jiske zyada cost nahi aata, not even more than 1% of the entire building. Okay, what is the cost of this tempered glass and this? Nothing, right? Compared to the mobile, it is nothing, absolutely nothing. ठीक है, उतना भी बिल्डर लोग नहीं करते हैं अनफॉर्चुनेटली. वो करना चाहिए. ओके, तो कैसे करेंगे, वही तो प्रश्न है, कैसे करेंगे. तो ये सब कुछ पढ़ना पड़ेगा उसके लिए. AC41 मॉडल क्या है, ये क्या है, कहाँ पे हिंज देना है, कैसे देना है, क्या करना है, स्ट्रेंथ वर्सेस डिफॉर्मेशन क्या है, क्या की स्टेप्स है. सी इनिशियली आई वुड लाइक टू टेल यू दैट देर आर, if you know that during the college days we have studied the working stress method, correct? Then it goes to the limit state method. Why we have disregarded the working stress method? Because working stress method, the deflection is not allowed, bending is not allowed, nothing is allowed. So the section sizes will become very big, but here in the limit state method it is allowed. करो बट कायदे में, इतना सा लिमिट करो, कायदे में करो. कायदे में मीन्स विद द लिमिट. व्हाट इज द लिमिट? परमिसिबल लिमिट. वेयर इज द परमिसिबल लिमिट? बेस्ड ऑन द सेफ्टी फैक्टर्स ऑफ सेफ्टी. Okay, so depending upon, so that's why the sizes of the beams, columns, everything has reduced. So it is more economical. That's why everybody is appreciated. Now this performance based is even more further, more brilliant method. That कहाँ पे क्या क्या करेंगे तो performance एकदम बढ़ेगा. How the performance rating will go up, shoot up. Okay, the strength versus deformation. Strength without ductility is meaningless. Okay, so all these parameters actually will be checking it. Assessment, ISC41 क्या norms है basically? The linear static method, linear dynamic, non-linear static, non-linear dynamic. NDI, which is and FNA. FNA is fast non-linear analysis. Okay, and this is direct integration, non-linear direct integration. So you required push-over analysis. Push-over analysis is a static form of the non-linear analysis, whereas the time history is the dynamic form of the non-linear analysis, NDI and FNA. Now somebody will say, sir, ये theory कैसे करते हैं, ये तो पल्ले नहीं पड़ रही है मेरे. I'm really getting pissed off with this. No problem, you go here, उसको check करो. Etabs में सीखना ना, कुछ क्लिक रहते हैं, खाली 8-10 क्लिक रहेंगे, क्लिक हियर, क्लिक हियर, क्लिक हियर, क्लिक, आसानी से कर दिया, एकदम ही आसानी से कर दिया इसको. ठीक है, खाली समझने की देर है. यहाँ से आपको फंक्शन लेना है, चेक करना है, then you go to the place where you will be applying the time history function. So let's say as a theory, as a load case. So here there is a time history, here there is a FNA, and this is the direct integration. Non-linear direct integration is this, FNA is this. So same way, कहाँ पे use होना है इसका, कैसे use होना है, क्यों यूज़ करना है, इंजेक्शन देना है बट कौन सा देना है, कब देना है, कितना मात्रा में देना है. That is what the doctor it is, otherwise you will become just a nurse. Got it? So this is how the assessment options are there, and there are these kind of features are there: non-linear static, non-linear dynamic, and also so many theory, a lot of theory is involved into this. Actually, this diagram is also very important. What are these actually? These are non-linear hinges. Non-linear hinges means जो चिल्लाते हैं ना ऐसे करेंगे तो अयो इधर दुख रहा है, correct? So here also you need to give the hinges because this should not be bending more. If it is bending more, it should start screaming and give the signal to my software. Then there is a signal here, there is a hinge here, there is a hinge here, there is a hinge here. So which hinge you will be using where? What is the hinge? Hinge is just like a camera, CCTV camera. CCTV camera के जगह पे आपने it scans basically who is doing what and all, correct? वहाँ पे आपने अगर suppose laser camera रख दिया, पता ही नहीं चलेगा who is what actually. Is a scan, you know the X-ray machine अगर आपने रख दिया, तो सारे सांगड़े आ जाएंगे. I mean like all the skeleton will be shown. So you really need to know that which kind of camera you need to use it, what kind of hinge that you need to use it. So this is all comes under the SC41 theory. This is FD relationship, force and deformation relationship and all actually. Somebody is saying, sir, how to visualize? Yes, how to visualize is also another question. Okay, I'll show you that. Give me a moment actually. So this is backbone curve. As I told you, पहले साइकिल चलेगी तो ऐसे चलेगी, ऐसे 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 चलेगी, है ना. साइकिल का जैसे जैसे स्पीड बढ़ेगा वैसे वैसे ऐसे साइकिल चलेगी, क्योंकि विदाउट फोर्स देयर इज अ डिफॉर्मेशन, करेक्ट. सो पहले तो साइकिल ऐसे चल रही है, बहुत मजदूरी करनी पड़ रही है, बट धीरे 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 साइकिल ऐसे चलेगी. Now cycle is something that you wanted to really have maximum deformation with the least speed, correct? ज़्यादा deformation चाहिए कम force में, तो cycle is best. But earthquake में building ज़्यादा झुकनी चाहिए without force, अयो, this is not something you want. So the behavior of this is to be considered as primary. The moment you go like this is not something which the structural engineer wants. That is the backbone theory. Okay, तो ऐसे काफ़ी सारे theories यहाँ पे mark की गई है, and these are the graphs actually which you will see. Understood? So based on this, we will be defining all this to see the performance of a structure. Okay, so how to check the performance? Now there is something called as long-term performance. For long-term performance, you have to go to the material. Let's say you go to the material, add a material. Let's say I'll go to the India, go to the concrete. Let's say I go to the M40 grade of concrete. Okay, then you go to the time dependent properties, go to the creep, and you need to refer the CBFIP code or ACI 209R code. Indian code नहीं है इधर, इंडियन कोड में ही नहीं है, कोड ही नहीं है इंडियन, तो यहाँ पे इस्टेब्लिश करने का सवाल ही नहीं आता है. ओके, अगर कोई डेथ रो पे पड़ा है, आपका बहुत ही करीबी रिश्तेदार है, तो क्या करेंगे आप? इंडिया में डॉक्टर नहीं है तो यूएस वाला डॉक्टर भैया उसको टिकट दे देंगे, होटल दे देंगे, भैया आ जाओ प्लीज़, हेल्प माय मदर और ब्रदर और somebody is dearer to me, करेक्ट. वैसे ही अगर बिल्डिंग में काफ़ी स्ट्रक्चर में काफ़ी सारे कुछ इश्यूज आपको फाइंड आउट करने हैं, इफ़ यू रियली वांट टू इम्प्रूव द परफॉर्मेंस ऑफ अ स्ट्रक्चर, यू हैव टू यूज़ द फॉरेन कोड्स. देयर इज चारा नहीं उसमें, ठीक है. तो हाउ टू यूज से, लेट्स से CBFIP 90 कोड है, तो ये दिस इज रिलेटिव ह्यूमिडिटी, कुछ 5-6 पैरामीटर्स रहते हैं खाली, ज़्यादा नहीं रहता है. कितने पैरामीटर्स हैं? 1 2 3 4 4 पैरामीटर हैं. वो ये बुक में से फाइंड आउट करने हैं, यहाँ पे डालना है, ओके करना है, ओके करना है, रन द एनालिसिस, गेट द रिजल्ट्स. सिंपल है. ऑपरेशनल लेवल इन Etabs इज़ वेरी सिंपल. थियोरेटिकल लेवल इज़ लिटिल डिफिकल्ट. ओके, तो वही आपको फाइंड आउट करना है. किस तरीके से फाइंड आउट करेंगे, क्या करेंगे, उसका पूरा नॉलेज आपको होना चाहिए टू इम्प्रूव द परफॉर्मेंस. मोबाइल आपका 1 लाख का है फॉर एग्जांपल, उसका लाइफ बढ़ाने के लिए आपने 200-400 रुपए का टेम्पर्ड ग्लास और कवर और ये सब कुछ लगाया है, करेक्ट है ना? क्योंकि क्या चाहिए, परफॉर्मेंस बढ़ाना है। कल मोबाइल लेके आए, आज ग्लास टूट गया, कैसा लगेगा आपको? वैसे ही आपने बिल्डिंग कंस्ट्रक्ट किया है, 1 साल के अंदर ही उतना बड़ा क्रैक ये वो सब आ गया, कैसे होगा? सुसाइड करने का जी करेगा, क्योंकि पूरा इन्वेस्टमेंट सब डाला उसमें। हाँ, फ्लैट नहीं है, घर नहीं है, लेकिन हफ्ता भर रहे बैंक का, ऐसा हालत हो जाता है, बिलीव मी। अंडरस्टूड? जैसे कार नहीं है, चोरी हो गया, लेकिन फिर भी कार का हफ्ता भर रहा है, हुआ है ऐसे कुछ कुछ लोगों का। तो मेक श्योर कि यू आर बेसिकली डीलिंग विथ ऑल दिस प्रैक्टिकली, परफेक्टली, so that the life of the structure can be enhanced. All right. So there are certain questions actually I would like to ask you guys. Uh, I think yes. How to visualize? How to visualize this? So I would like to say that actually how to visualize is, if you run the analysis from here, the first visualization, many things are given in the terms of the display. Okay. So first visualization is actually you go to the display and see the behavior of the structure in the different options. So first one is this. This is how you visualize the dead load deflection, how it is happening. Then you go to the different displacement areas. Actually, how do you check the spec X? Okay, so deflection against the X direction and the spectral X direction, how the visualization is happening. So all these parameters through this contour diagram and all you can easily visualize. There are other options actually. You can go to the combined response plot, which I have already shown it to you guys. Another option is actually you can get this particular graphs, different graphs, that how much force is applied, how it is applied. So there are varied variety of different options are there. So let's say there are certain plot functions actually are there. So this is the time and this is the effects and all actually. The forces are acting on it. Okay, so based on the time, this is the time period going in this particular direction, and you can see that how much is the base force in the fx direction, kitna force hai, how much. Based on the force actually it will applied, and you can also give certain functionalities and all actually from here. See here, there are certain functionalities which are a little bit advanced actually. You need to find out that column forces, beam forces, joint acceleration, base reaction, story forces, energy diagram, acceptable DC ratios. DC is the demand versus the capacity ratios. So ऐसे कई सारे tools यहाँ पे दिए हुए हैं. Non-linear hinges भी दिए हुए हैं. See, look at this. ये कौन सा hinge है? Suppose this is story 5. Okay, this is the hinge parameter. Okay, so based on the requirement actually, let's say this is the frame, I wanted to see the column, the beam, sorry. So you can see that this is the center point and the force is going only up to here and here. If the force is going from beyond this point or beyond this point, what is this actually? This comes under the negative bending moment diagram. This comes under the positive bending moment diagram. Okay, you know that the forces are reversal. Earthquake कहाँ से आएगा? इस direction में आएगा या इस direction में आएगा? पता नहीं चलेगा. Okay, so based on that, actually, you will decide that how does it work and all. All right. So these are certain visualization parameters are there, from which you can get the summary report, detailed report, many other things, and you can get the printout and all. Actually, all this. Alright, so hinge results also, you can get the tables also if you want. Actually, from here there are so many tables are there actually through which you can visualize it. Alright, so these are many different parameters are there through which you can find out the behavior of the structure, stability of the structure, performance of a structure and all actually. आपकी building लंबी रहनी चाहिए, आयु उसकी बड़ी होनी चाहिए. जो कोई छोटा बच्चा आता है आप आशीर्वाद देते हो उसको, आयुष्मान भव, आयुष्य ज़्यादा बढ़े आपकी, जिंदा ज़्यादा, यानी सुख मिले, शांति मिले और आयु बढ़े। वैसे ही आप स्ट्रक्चरल इंजीनियर हो, आप सिविल इंजीनियर हो, आप ऐसा चाहने की कोशिश करो कि ये बिल्डिंग का आयु कैसे बढ़ेगा। तो ड्यूरेबिलिटी पैरामीटर, स्ट्रक्चरल डिजाइनिंग पैरामीटर, ग्रेड ऑफ द कंक्रीट, डक्टाइल डिटेलिंग, डिटेलिंग ऑफ द स्ट्रक्चर, इरेक्शन ऑफ द स्ट्रक्चर, फैब्रिकेशन ऑफ द स्ट्रक्चर, शटरिंग, सेंटरिंग, bar bending, you need to make sure that the concreting is done, vibration is done, cube testing is done, proper testing, materials, everything. It is not only the designing parameter, it is also the execution parameters. All these parameters, if you are having 100 saal, 200 saal, believe me, actually one of my friend who was his daughter was there in London actually. ओके 350 ईयर्स की ओल्ड बिल्डिंग में वो रहती थी। 350 ईयर्स ओल्ड, नॉट 35 ईयर्स, 350 ईयर्स ओल्ड बिल्डिंग में वो रहती थी। शी हैज़ डन द MS इन आर्किटेक्चर। ओके, एंड शी सेड दैट इट वाज वेरी न्यू बिल्डिंग। यहाँ पे 30 साल की बिल्डिंग तुड़वाने की कोशिश करते हैं लोग। 30 ईयर्स, क्या स्क्वायर फुट का रेट चल रहा है अभी, क्या फ़ायदा इसका? 1,000 रुपए पर स्क्वायर फुट है भैया, 30 साल में तोड़वा रहे हैं उसको। 350 साल पुरानी जिंदा रहने की ताकत रखते हैं कंक्रीट स्ट्रक्चर्स के अंदर, आप 30 साल में तोड़वा रहे हैं उसको। 30 years you are demolishing, right? So it is very important guys that you need to identify that how you can reduce actually the burden of this real estate. मान लो एक एग्जाम्पल मैं बता रहा हूँ, यहाँ पे कोई दिल्ली का है एक्चुअली, तो दिल्ली में सारे बिल्डिंग अगले 30 साल में तुड़वा के वापस कंस्ट्रक्ट करने हैं। 30 नहीं, चलो 50 साल में, 50 ईयर्स में सारे बिल्डिंग तुड़वाने हैं और वापस कंस्ट्रक्ट करने। तो जो गार्बेज मटेरियल है भैया डालोगे कहाँ पे? Where the hell you are going to put all this? So NDT construction waste is going to be alarming situation. Okay, so we need to see that how we can improve the life structure so that such kind of problems will not arise, or even if it is arising, it is delayed quite a lot, so that the new inventions and technologies can be happened for the new structures or for demolishing and all the other types of structures. So we as a structural engineer, I would invite from all this particular our channel to everybody to design the structures properly, how to improve the life, how to make sure that this kind of things are happening. Okay, beautiful graphs are created, beautiful designs are happening, but believe me, 5% भी लोग use नहीं करते इस technology को। 5% consultants are also not using this technology, जो आपके most of the consultancy offices they are having this, नहीं हो रहे हैं। बहुत दुख होता है actually, believe me, unfortunately, but it is not happening. Okay, so please make sure that you guys are using such kind of technology as much as possible. Use this technology से बहुत कुछ हो सकता है। Okay, even the cancer patient actually उसका recovery 2-3 साल 5 साल वो जिंदा रह सकता है। करेक्ट है ना? वो टेक्नोलॉजी है, chemotherapy, this one, that one, that through certain technology you can at least achieve certain things. I have seen that actually, so many ekdam medical science, every particular science has been scaled up in such a way. AI technology, artificial intelligence and all. Okay, so we need to see that how this can be happening. Okay, so we will see that. Let's say this is another graphs actually I would like to show you. Look at this. Elastic, kinematic, isotropics, then all these are different types of ये cycles है actually. This is cycle. ऐसी चलेगी तो कैसे होगा, ऐसी चलेगी तो कैसे होगा, ऐसी चलेगी तो कैसे होगा, ऐसी चलेगी तो कैसे होगा. Takeda, pivot, and reinforced concrete. These are basically the graphs. Okay, so let's say for example how this graph is there. Compression में अच्छे है, tension में कम है. Okay, so these are different hysteresis loop actually. Hysteresis loop यानी कि cycle है. ये गाँव वाली cycle है. ये जो runner racing की cycle है. तो automatically you will see that कम पैडल मारने के बाद भी it is going like this. Okay, So this is the behavior actually of the hysteresis loop. Okay, and automatically you will see that how the things are happening, force, deformations, and many things are there actually. We generally train you in all these cases, guys. Okay, so thank you so much for giving your time. I'm sure that with this particular kind of webinars, you might have learned quite a lot of things actually. And coming 30th, we are starting the master study in structural engineering course. If you are really interested, please immediately ping on the WhatsApp number given in the chat box. Immediately you call, because very limited number of seats are there. And at the same time, I would like to tell you that we do not make that 500 800 people उनके बड़ी ऐसी क्लास नहीं लेते. जिंदा बच्चे लेते हैं जिनको whomsoever really wanted to upgrade their career to the international level. ये सारी चीज़ें दुबई में 15 साल पहले हम लोग करते थे, अभी भी इंडिया में नहीं हो रही है, लोगों को पता भी नहीं है. ठीक है, तो ये यूज़ करनी है उसको. अभी भी लॉगरिथमिक बुक यूज़ कर रहे भैया, कैलकुलेटर आ गया, कंप्यूटर आ गया, एआई आ गया, फिर भी नहीं, लॉग ही यूज़ करना है. करो अभी, मरो, और क्या है. Make sure that your clients, your company, your other people actually are getting used to this kind of industry standards. Okay, this kind of technology. वो किया क्यों है? US Resiliency Council है, इधर तो काउंसिल भी नहीं बने हैं. विद दिस, ये माध्यम की वजह से एक्चुअली में कोई पॉलिटिशियन या ऐसे कुछ कोई देख रहा है, बाद में एक वीडियो वो यूट्यूब पे भी जाएगा, काफ़ी सारे लोग भी देखेंगे इसको. तो मैं ये चाहता हूँ कि ऐसे कोड्स अपने इंडिया में पैदा हो, और वो कोड जो है उसका कंपल्शन बिल्डर्स और डेवलपर्स के साथ हो जाए. आई मीन ये आपको यूज़ करना है, ये कोड के ज़रिए आपको ये यूज़ करना है ताकि बिल्डिंग का लाइफ बढ़िया हो जाए. अरबों खरबों की बिल्डिंग बनती है, 5-5 करोड़ के फ्लैट रहते हैं, कौन सा मार्बल लगाना है उसके ऊपर हज़ारों करोड़ खर्च हो जाते हैं, लेकिन कॉलम बीम जो मेन स्केलेटन है उसके ऊपर खर्च नहीं होता है. बहुत दुख होता है. ओके, सो मेक श्योर दैट आपका स्केलेटन अच्छा हो. क्या कलर पेंट चेंज कर सकते हैं, फ्लोरिंग चेंज कर सकते हैं हर 5 साल के बाद. कॉलम को कैसे चेंज करेंगे, फाउंडेशन को कैसे चेंज करेंगे, नहीं होगा. वही तो मेजर लाइफ है बिल्डिंग का. मेक श्योर दैट यू आर यूजिंग दैट पर्टिकुलर टेक्नोलॉजी to improve upon these kind of things. Understood? So I'm sure that many of you really would be gaining out of this particular video. ये वीडियो यूट्यूब पे भी रहेगा. बाद में जो भी नए लोग हैं, प्लीज़ सब्सक्राइब आवर चैनल. ओके, एंड ये वीडियो काफ़ी सारे लोगों तक पहुँचाइए. एवरी फ्राइडे हम लोग ऐसा वेबिनार लेके आ रहे हैं. बहुत ज़्यादा लोगों तक ये पहुँचाने के लिए प्लीज़ सहयोग करिए. ठीक है, थैंक यू सो मच फॉर गिविंग योर टाइम, and we'll see you on the next Friday, same time, same place. Thank you so much. Bye bye.